Good morning one and all, and welcome to the video. This video I'll be sharing how to essentially dump your reports from Elasticsearch into a data lake. So here is the business use case. You have been asked to design a REST API or a microservice where this essentially the in the REST API they would be passing you the parameters, right? And then you need to develop a system where you can query the entire Elasticsearch, and you have 100 million plus records. So your API essentially needs to query the Elasticsearch, and essentially, once you query the data, you need to normalize the data, and then essentially dump the data to the data lake. How do we implement this system? I'm going to talk about that. And the reason, before going a little bit here, but we already know that Kibana has a reporting. Well, if you want to download massive report, like if the number of hits are like 30 million, 20 million, it's going to fail, right? So you need to develop your own system. So I'm going to talk something that I have designed in my company, and I've provided to the, some of the marketing people, they needed that data. So I provided, I wrote this, I implemented this system, and essentially it generates these reports, CSV, and it dumps on the data lake on S3 where they can go and download it. So I'm just going to show you a high level overview in this video, okay? All right, the system looks like this. Yeah, it's actually easy. Let me make sure I turn my webcam on. For some reason, seems like it's disconnected. All right, we are back. So it's a very easy system. So the user would essentially make a request to the API gateway. So he will be passing in the query parameters. Let's say, let's assume it's a data set of movie or any data set. So those parameters would be passed here. Then those parameters, the API gateway would pass to a Lambda. The Lambda has to now essentially, serialize those parameters as a JSON string, and it would pass to the batch function. So in the batch function, you'll say Python, then the name of the file, and then hyphen, you'll pass that essentially payload that the user passed. Once the user passed that payload, now in the batch function, AWS batch, you have to essentially implement a query generator. So based on the query, whatever the user passed, for example, let's hypothetical, say the user passed in, if you're taking an example of, let's say, let's take an easy example, right? Let's take job title and city. He wants all the jobs in particular city, right? So you would, query the Elasticsearch, and you would have essentially, what you call as a you have to implement a pagination, right? Because you cannot query all the, let's say you have 100 million, you cannot query all that 80 million records, right? So essentially you will query at 500 or 1000 would be a batch size there. So you do that, you take the first batch, then essentially you will go to the data normalization. You would normalize that data, essentially, remove the white space and do all that. Once that is done, what you will have to do here is essentially, excuse me. Once you normalize the data, you essentially create a pandas data frame, and once the pandas data frame is created, then essentially you have to create your so you'll create a string IO buffer, and then you would write the buffer to Amazon S3 in the data lake. So this is how the system should work. I did implement this in my company as well. For the reporting purposes, I developed a custom solution for them. So I want to show you one small thing on how you would organize your data. So say whatever let's say this is something related to marketing or whatever it is. So we'll have a base folder name here, whatever app name, right? Then you should have a year. This is how you should partition your data lake as well. So let's just try it here. Month, you'll have a day, and here we need one more partition on whatever the user was searching. Say he searched for whatever XYZ. So create a unique what you call that. For example, let's say the user searched for software engineer in Stanford, right? So you would add that partition here, and for that user now. So for that user, you'll have all the CSV1, CSV2, CSV3, and this is how you want to structure your data lake properly, right? This is exactly how you want to do it. Let's just color this up. So by doing that, what you are essentially doing is now, let me make this a little bit big, and let me bring this a bit here. So essentially, this allows you to, have a structure in your data lake, right? Now, once that's done, now you also want to set up a lifecycle policy, which means that remember, they will be using this report and then they might not use it. So you wanna set up an infrequent access, because after 60 or 180 days, they should move your S3 standard access should move to infrequent access, and then it should essentially move to Glacier event, and eventually should move to Glacier Deep Archive. So essentially to save cost, right? But this is the structure you want to follow when you're doing that. This is the architecture, right? Should be very, very easy. I have implemented it in my company for their use cases. I'll share some of the pseudocode for you that I have written. So essentially the logic here, as I said, this is a very pseudocode. I have removed a lot of things, but I'm just giving you sort of an idea here. Hopefully, if I can bring this here a bit. So the logic essentially is you'll have a master class here. Give me 1 sec while I switch this back. Okay. So the pseudocode logic essentially is, your batch function would be invoked by sysargs, right? So you'll pass that JSON payload in your batch function. You would serialize that, and you would pass it to your class. So whatever parameter you are taking, it doesn't matter. As I said, I'm just providing a pseudo logic here. So the pseudo logic says take the parameters. For the first step is you would call the query generator, and I have a scaffold here. Essentially, let me see, where is that? So get query generator, you'll implement your query. I've said that, write your query here. So the first step was essentially based on the parameter that user passes through API gateway and Lambda that is received on the batch job. You have to serialize those parameters as a JSON, because you're passing a string JSON there, right? So heading over back to this. So once you have the query, then you need to query the Elasticsearch now. So essentially before that, create an instance of AWS, right? Then essentially pseudocode, like as I said, not the final code. Then you create an instance of a class Elasticsearch. Then essentially you would perform a search.search method, and you want to do scrolling. You want to save the scroll for 10 minutes. Once that's done, now for each scroll, right, for every single scroll, what you want to do is you'll have a while loop. So while scroll is greater than 0, this is the logic, right? So if the scroll is greater than 0, take the page, take the data, then essentially call the data normalization class. So this essentially class, whatever data you are asking for, this would normalize that data. It would append to the array, the global array right here. Now what it would happen is essentially once that is done, you will create a pandas data frame, and then you will dump that pandas data frame to the AWS S3. So essentially what this does is essentially for every single epoch of scrolling, this would dump that data on the data lake on Amazon S3 essentially. So that's that. Once that is done, and that's pretty much it, right? So now you have the data on the data lake. So let me collapse that a little bit. So essentially on high level, you need a couple of classes, right? You need a query generator class basically, which would generate the query. Then essentially you need an Elasticsearch class essentially that would search, and it would implement the pagination. When the pagination is done, you want to normalize the data, convert it into a pandas data frame. Once it's converted into a pandas data frame, then you want to dump it on S3. So essentially that's when you will have your job logger or whatever class. Again, pseudocode I have written here, so you'll create, once you have a pandas data frame, you create a string IO buffer object, you say this one, and then you say put files, right? So this will essentially put the data into data lake. This is how you can generate report efficiently while querying the Elasticsearch. So if you have massive amount of documents and if you want to generate reporting, and if Kibana is not working for you, this is a solution I would recommend. So what this does is this would place your request of a user into a queue, in a job queue, and from there the batch would be invoked, which is running on ECS, and essentially you would do all this process and dump the files on the data lake, and then the user after 1 or 2 hours can go and download the files. Hope this is useful. If you have any more questions, list your questions in the comment section below, and I'll be very happy to have a conversation on this. But that's it for this video. If you know any plugins for if you know any custom plugins, do let me know. The reason I see as this as a system is because Elasticsearch, you might store your data in the Elasticsearch in a particular format, but the user, for the reporting needs, you might need to format that data, right, or in a particular format. That's the reason this system will allow you to, do all that job. Of course, you can add more and more blocks on that, but this is the rough idea on how you want to do that. So thank you so much for watching. Hope you have enjoyed it, and I will see you guys in the upcoming next video.